Students, our next topic is magnetic field at a point on the axis of circular coil carrying current. Consider a circular coil of radius A with center O. Let plane of the coil is perpendicular to the plane of paper. Let a current I is flowing in the coil in the direction shown in figure. Let P is a point on the axis of the coil at a distance x from its center. Therefore, OP is equal to x. Consider two small elements, each of length dl. Consider two small elements, each of length dl at C and D, which are situated at diametrically opposite edges. Then, by Pythagoras theorem, PC is equal to a square plus x square का root, and similarly PD is also equal to this. Let angle CPO and angle DPO is equal to phi. According to Biot-Savart law, the magnitude of magnetic field induction at P due to current element ideal vector at C, this is dB is equal to mu naught upon 4 pi ideal sin 90 upon r square. Because radius of the circular coil is small, A is small, therefore theta is 90. Therefore, this becomes mu naught upon 4 pi ideal upon r square, because sin 90 is 1. Now, in place of r square, we can write a square plus x square. Therefore, this becomes mu naught upon 4 pi ideal upon a square plus x square. We call it equation 1. Now, the direction of dB is perpendicular to the plane containing dl vector and r vector, or we can say direction of dB is in the plane perpendicular to dl vector and r vector, and by right hand rule it is acting along PE perpendicular to CP. Similarly, the magnitude of magnetic field at point P due to current element ideal vector at D, this is dB dash, this will be also mu naught upon 4 pi ideal sin 90 upon r square, and we can write it as mu naught upon 4 pi ideal upon a square plus x square, and it acts along PF perpendicular to PD. Now, from 1 and 2 we see that as right hand sides are equal, therefore left hand sides are also equal. Therefore dB, therefore as right hand sides are equal, therefore left hand sides are also equal. Therefore dB is equal to dB dash is equal to mu naught upon 4 pi ideal upon a square plus x square. Here angle YPE is equal to y dash PF is equal to CPO is equal to DPO is equal to phi. We can see that. Therefore dB can be resolved into two rectangular components. One is dB cos phi acting along Py and dB sin phi acting along Px. Similarly, dB dash can be resolved into two rectangular components. dB dash cos phi act along Py dash and dB dash sin phi along Px. As dB is equal to dB dash, dB और dB dash बराबर हैं, therefore component dB cos phi along Py and dB dash cos phi along Py dash, they being equal and opposite, they cancel each other. However, their components along Px, they being in same direction, they add. Therefore, this is true. This is true for all the pair of diametrically opposite elements of the circular coil. Therefore, total magnetic field at point P due to current through whole circular coil, this is given by integration of dB sin phi, because along the axis the components are dB sin phi. Integration of dB sin phi, putting the value of dB, and we get this. Now taking the constant outside, mu naught I sin phi upon 4 pi a square plus x square integration of dl. Since sin phi in this right triangle sin phi is equal to perpendicular upon hypotenuse, perpendicular is a, hypotenuse is a square plus x square ka root. Therefore sin phi is this, and integration of dl, this is equal to circumference of the circular coil, which is 2 pi a. Therefore, substituting value of sin phi and integration of dl, we get this. Therefore, we can rewrite it as mu naught 2 pi a square into I upon 4 pi a square plus x square raised to power 3 upon 2, which is acting along px, that is the axis. If there are n turns in the coil, then we multiply this whole term by n. This becomes B. This is the total magnetic field at a point on the axis of the circular coil carrying current, and it acts along OX. Now the special cases. When the point P lies on the center of the circular coil, then x is equal to 0. If the point P lies at the center of the circular coil, then x becomes 0. Therefore, substituting x is equal to 0 in this equation, we get this. Second, when point P is very far away from the center of the coil, if the point P is very large distance from the center of the coil, then x is very greater than a. Therefore, x square plus a square, this can be written as x square. X square plus a square can be written as x square, because a square can be neglected in comparison of x square. Therefore, now putting here in place of a square plus x square, we put x square. Therefore, this becomes mu naught upon 4 pi 2 pi n a square I upon x cube, and we can write it as 2n into pi a square into I upon x cube. Pi a square is equal to a, area of the current loop. This becomes mu naught upon 4 pi 2n a I upon x cube. Now NAI, this is called magnetic dipole moment of the current loop. Therefore, B is equal to mu naught 2m upon 4 pi x cube. Therefore, the current carrying loop, this behaves as a magnetic dipole which produce magnetic field. If the current in the upper phase of the current loop is anti-clockwise, then upper phase behaves like north pole and lower phase behave like south pole. And if the direction of current on the upper phase of the coil is clockwise, then upper phase behaves like south pole, lower phase behaves as north pole. Unit of magnetic dipole moment is, unit of current is ampere, unit of area is meter square, ampere meter square. Therefore, current carrying loop behave like a magnetic dipole. When the point P lies on the axis of the coil at a distance equal to radius, that is when x is equal to a, then in this equation we put, in place of x we put a. Therefore, this becomes mu naught upon 4 pi 2 pi n a square I upon a square plus a square raised to power 3 upon 2. This becomes this. The variation of magnetic field with distance from the center of the coil, with the variation of magnetic field with the distance of the point from the center of the coil on the axis. This is shown in this figure. This means magnetic field is maximum at a point at the center of the coil, and when the distance of the point from the center of the coil increase, magnetic field decrease. Distance is increasing, magnetic field is decreasing.